Welcome to the Royal University of Phnom Penh, Cambodia. This presentation is about data collection, which will be focused on what you will be able to do after going through this kind of presentation. And you will learn what the data is, the difference between data and statistics, and you will be introduced to types of data. And the last part of this presentation, you will learn how to do data collection. After you have gone through this presentation, you should be able to differentiate types of data, categorize data in according to the nature of data generated tools, and you should be able to apply appropriate method to collect data. To understand the data collection, it is important to understand what the data is. In short, it's a collection of measurements or observations divided into two different types, known as qualitative and quantitative data, which are further classified into further. To understand the process of data collection, it is important to understand what the data is. In short, it's a collection of measurements or observations divided into two different types, qualitative and quantitative data, which are further classified into four types data. The fourth type of data, known as nominate. To do the data collection, it is important to understand what the data is. In short, it's a collection of measurements or observations divided into two different types, qualitative and quantitative data, which are further classified into four different types of data. And the four different types of data is known as nominal data, ordinal data, discrete data, and continuous data. In these types of data, you learn that the qualitative and quantitative. In qualitative, it refers to the words, image, observations, conversations, or even a photograph. And these words or terms are classified into nominal data or ordinal data. For quantitative, it normally refers to numbers, tests, counting, or a measuring. And these words or these numbers are classified into discrete or continuous data. So as you learn that the type of data are tools, these the quantitative data are, as you have just learned that the type of data are classified into tools. So quantitative data, the data that can be measured with the numbers such as the duration or the speed. And these numbers, as you know that, is the discrete. In this part, you can see that quantitative data refer to the data that can be deal with the numbers such as duration or speed. And the quantitative data it divided into two, that the discrete data. So you just learned that the two different types of data are quantitative and qualitative. In quantitative categories, data refer to the data that can be measured with numbers, such as duration of speed. And this number or duration of speed can be classified into discrete and the continuous data. In the discrete data, it refers to the whole number that can be broken down, such as the number of items. And for continuous data, it refers to the number that can be broken down, such as a height or weight. In addition to this, continuous data also classified into two different types, known as interval data, which is about the number which known of different. As you have just learned, the two different types of data are quantitative and qualitative. In quantitative category, data is about the thing that measure with the numbers, such as duration of speech. And in these categories, the rise, you have just learned that the two different types of data, as you have just learned that the two types of data are quantitative and qualitative. In the category of quantitative data, can be measured about the number, such as duration or speed. So the duration of speech or numbers can be categorized into discrete data or continuous data. The discrete data can be the numbers that can't be broken down, such as a number of items. So we cannot separate this kind of item further. And for continuous data, the number that can be broken down, such as height or weight, we can go or make it smaller or to another category, which is known as interval data and ratio data. In interval data, the number that which known as differences between a variable, such as the time or the period of times. For the ratio data, it refers to the number that you measurable intervals where difference can be determined, such as a height or weight. For further data explanation regarding to qualitative, you know that the qualitative data refer to non-numerical data that categorical, such as yes or no responses, or just the color or the eye colors or the category or different group. So these qualitative data can be classified into nominal or ordinal data. So the qualitative category known as non-numerical data that is categorical, such as yes or no responses or yes or no. So the qualitative data refer to non-numerical data that is categorical, such as yes or no response, or it's just the color of group, such as eye colors or hair color, something related to the group, which is words or So the qualitative data refer to non-numerical data, which is categorical, such as yes or no response, or the color of hair or the color of eyes. And these non-numerical data are classified into nominal data or ordinal data. In nominal data, used for naming variables such as hair colors, eye colors, the color of the skin, the group of people, and the ordinal data used to describe the order of value such as 1 for happy, 2 for neutral, and 3 for unhappy. So you can classify these kind of value into ordinal data. So you can see different type of data, but for this part, you have to understand qualitative data or quantitative data is not enough. So you have to be able to differentiate between what the data or what is called statistics. So in this part, you can see data refer to data set, machine readables data files, data file for statistical software programs. Therefore, data can be analyzed and interpreted using statistical procedures to answer question why or how. Data is used to create a new information and knowledge. Understanding qualitative and quantitative data is not enough. You should be able to differentiate data and statistics. So from this part, you can see that data can identify as data set, or it can be readable, or it can be a file for statistical software program. The machine can be used, or the program can be. Understanding only quantitative and qualitative data is not enough. Therefore, you should be able to differentiate between data and statistics. You have to define, or you have to be clear what is called data, what is called statistic. From this part of presentation, you can see data here can be a data set. If the data which machine can read, or data file for statistical software programs. Therefore, data can be understanding the terminology of quantitative and qualitative data is not enough. Therefore, you should be able to differentiate between data and statistics. Or you have to be able to explain what the data and what the statistic is. So data can be a data set, the machine readables data files, or data file for statistical software programs. Data can be analyzed and interpreted using statistical procedures to answer question why or how. Thus, data is used to create a new information and knowledge. In other way, statistics can be about the statistical table, chart, or graph. The thing we reported numbers or represented the percentage in an article. A statistical understanding the terminology of quantitative and qualitative data is not enough. Therefore, you should be able to differentiate the data and statistics. Understanding the terminology of quantitative and qualitative data is not enough to understand the data collection. Therefore, you have to be able to differentiate the data and statistics. This, you can see that data can be classified as data set. The data can be used. Understanding the terminology of quantitative and qualitative data is not good enough. Therefore, you should be able to differentiate the data and statistics. So, data can be data set, machine readable data files, data file for statistical software programs. Data can be analyzed and interpreted using statistical procedure to answer question why or how. Data is used to create a new information and knowledge. Understanding the terminology of quantitative and qualitative data is not enough to understand the data collection. Therefore, you should be able to understanding the terminology of quantitative and qualitative data is not enough. Therefore, it is important for you to be able to differentiate data and statistics. You should be able to tell what the data is or what a statistic is. So data can be data set, machine readable data files for statistical software programs. Data can be analyzed and interpreted using statistical procedures. Understanding the terminology of quantitative and qualitative data is not enough. Therefore, you should be able to differentiate the data and the statistics. Data can be data set, machine readable data files for statistical software program. Data can be analyzed and interpreted using statistical procedures to answer why or how. Data is used to create a new information and knowledge, while the statistics refer to while the statistic can be statistical tables, charts, and graphs. It reported numbers and percentage in an article. A static understanding the terminology of quantitative and qualitative data is not enough. Therefore, you should be able to differentiate data and statistics. Here, data can be defined as data set, machine readable data file for statistical software programs. Data can be analyzed and interpreted using statistical procedures to answer why or how. Data is used to create new information and knowledge, while statistics can be statistical tables, charts, and graphs reported numbers and percentages in an article. A statistical understanding the terminology of quantitative and qualitative data is not enough. Therefore, you should be able to differentiate data and statistics. Data can be dataset, machine readables, data files for statistical software programs. Data can be analyzed and interpreted using statistical procedures to answer question why or how. Data can be used to create new information and knowledge. While statistic can be statistical tables, charts, and graphs, reported numbers and percentages in an article. A statistic will answer how much or how many. A statistic repeats a predefined observation about realities. Statistics are the result of data analysis. Statistics are the result of data analysis. They usually come in the form of a table or chart. This is what a statistical table looks like. So from this, you can see that the information regarding to the numbers can be organized. Here is the example of statistic. This table here is an example of statistics. This table presents the answer of question about how you currently get a stable job. So you can see they present the information related to yes or no. And it can be about the how many people answer yes, how many people answer no, and how many population join in this Here is an example of a statistic which answer the question if you get a job or if you currently got a stable job. So the statistic can be organized into the frequency, percentage, or accumulative percentage. From this table, you can see the number of people who answer yes and the number of people who answer no. And you can see how many people answer this question. And it can be calculated into the percentage or can be accumulated percentage. This table show you about the statistic. Now, you should be able to see the clear meaning of quantitative data and qualitative data. From those kind, now we are discussing the qualitative data and the quantitative data. The quantitative, you have just learned the differences between data and statistics. Now, you should be able to, you have just recognized the differences between data and statistics. Here, you can see we are discussing. You have just recognized the differences between data and statistics. Here you should be able to differentiate the differences between qualitative data and quantitative data. Qualitative data refer to the information about qualities or information that cannot be measured. It's usually a descriptive and textual. Example including someone's eye colors or the type of car they drive. In a surveys or in surveys, it often used to categorize yes or no answers, as we learned from the previous graph. Yeah, you have just learned the differences between data and statistics, and here you should be you have just learned the differences between data and statistics. Here you should be able to differentiate qualitative data and quantitative data. Qualitative data refer to information about qualities or information that can be measured. It's usually descriptive and textual. Examples include someone's eyes colors or the type of car they drive. In surveys, it often used to categorize yes or no answers. Quantitative data is a numerical. It's used to define information that can be counted. Some examples of quantitative data include distance, speed, height, length, and even weight. It is easy to remember that difference between qualitative and quantitative data, as one refers to quality and the other refers to quantity. A bookshelf, for example, may have 100 books on its shelves and can be 100 centimeters tall. These are quantitative data points. The color of the bookshelves, red, is a qualitative data point. How can we use quantitative and qualitative data in statistics? One data scientist, how can we use quantitative and qualitative data in statistics? One, data scientists have a conclusive data set from their sample. They can start to use the information to draw descriptions and conclusions. To do this, they can use both descriptive and inferential statistics. Descriptive statistics have demonstrate, represent, analyze, and summarize the findings contained in a sample. They present data in an easy to understand and presentable. Descriptive statistics have demonstrate, represent, analyze, and summarize the findings contained in a sample. They present data in an easy to understand and presentable form, such as a table or graph. Without description, the data would be in its raw form with no explanation. In descriptive statistics, one way data scientists can describe statistics is using frequent counts or frequency statistics, which describe the number of times and variable exists in data set. For example, the number of people with blue eyes and the number of people with a dry eye. For example, the data of people with blue eyes or the number of people with a driver license in the sample. In descriptive statistics, one way data scientists can describe statistics is using frequency counts or frequency statistics, which describe the number of times a variable exists in the data set. For example, the number of people with blue eyes or the number of people with driver license in the sample can be counted by frequency. Other examples include qualification of education, such as high school diploma, a university degree or doctorate, and categories of material status, such as single, married, or divorced. Frequency data is a form of discrete data as parts of the values can't be broken down. To calculate continuous data points, such as say, data scientists can use central tendency statistics instead. To do this, they find the mean or the average of the data points. Using the age example, this can tell them the average age of participants in the samples. While data scientists can draw summary from the use of descriptive statistics and present them in an understandable form, they can't necessarily. While data scientists can draw summaries from the use of descriptive statistics and present them in an understandable form, they can't necessarily draw conclusion. While data scientists can draw summaries from the use of descriptive statistics and present them in an understandable. While data scientists can draw summaries from the use of descriptive statistics and present them in an understandable form, they can't necessarily draw the conclusion. While data scientists can draw summaries, while data scientists can draw summary from the use of descriptive statistics and present them in an understandable form, while data scientists can draw summary, while data scientists can draw summaries from the use of descriptive statistics and present them in an understandable form, they can't necessarily draw conclusions. That's where the inferential statistics come in. Here is about the inferential statistics. Inferential statistics are used to develop a hypothesis from the data set. It would be impossible to get data from an entire population. So, data scientists can use inferentials. Here is about inferential statistics. Inferential statistics are used to develop a hypothesis from the data set. It would be impossible to get data from an entire population, so data scientists can use inferential statistics to extrapolate. Here is about inferential statistics. Inferential statistics are used to develop a hypothesis from the data set. It would be impossible to get data from an entire population, so data scientists can use inferential statistics to extrapolate their results. Using these statistics, they can make generalizations and predictions about a wider sample group, even if they haven't surveyed them all. An example of using inferential statistics is in an election. Even before the entire country has voted, data scientists can use this kind of statistic to make assumptions regarding who might win based on a smaller sample size. So, qualitative or categorical data. Qualitative or categorical data is data that can't be measured or counted in the form of numbers. These types of data are sorted by category, not by number. That's why it is also known as categorical data. Qualitative data sometimes can be called a categorical data. Qualitative or categorical. Qualitative data sometimes called categorical data. Qualitative or categorical data is data that can't be measured or counted in the form of numbers. These types of data are sorted by category, not by numbers. That's why it is also known as categorical data. This data consists of audio, image, symbols, or text. The gender of a person, for example, male or female, or other, is qualitative data. Qualitative data tell about the perception of people. This data help market researchers understand the customer's taste and then design their ideas and categorize accordingly.
The topics covered thus far.
Here you can see the differences between inferential data and descriptive data from the video shows.
The topics covered thus far have all been aimed at descriptive statistics. That is, describing the data we've collected. There's an entire other field of statistics known as inferential statistics that's aimed at drawing conclusions about a population of individuals based only on a sample of individuals from that population. Imagine I want to understand what proportion of all Udacity students drink coffee. We know you're busy, and in order to get projects in on time, we assume you all must drink a ton of coffee. I send out an email to all Udacity alumni and current students asking the question, do you drink coffee? For purposes of this exercise, let's say the list contained 100,000 emails. Unfortunately, not everyone responds to my email blast. Some of the emails don't even go through. Therefore, I only receive 5,000 responses. I find that 73% of the individuals that responded to my email blast say they do drink coffee. Descriptive statistics is about describing the data we have. That is, any information we have and share regarding the 5,000 responses is descriptive. Inferential statistics is about drawing conclusions regarding the coffee drinking habits of all Udacity students only using the data from the 5,000 responses. Therefore, inferential statistics in our example is all about drawing conclusions regarding all 100,000 Udacity students using only the 5,000 responses from our sample. The general language associated with this scenario is as shown here. We have a population, which is our entire group of interest. In our case, the 100,000 students. We collect a subset from this population, which we call a sample. In our case, the 5,000 students. Any numeric summary calculated from the sample is called a statistic. In our case, the 73% of the 5,000 that drink coffee. This 73% is the statistic. A numeric summary of the population is known as a parameter. In our case, we don't know this value, as it's a number that requires information from all Udacity students. Drawing conclusions regarding a parameter based on our statistics is known as inference.
So you can see the differences between inferential and descriptive statistics explained in this video.
The topics covered thus far have all been aimed at descriptive.
Now we are talking about the qualitative, which is related to nominal data. So nominal data is used to label variables without any orders or quantitative values. The color of hairs can be considered normal data, as one color can't be compared with another color. The name nominal comes from the Latin name nomen, which means name. With the help of nominal data, we can't do any numerical. The name of nominals come from the Latin names nomen, which means name. With the help of nominal data, we can't do any numerical tasks or can't give any order to sort the data. These data don't have any meaningful orders. Their values are distributed into distinct categories. The name nominals comes from the Latin name nomen, which means name. With the help of nominal data, we can't do any numerical tasks or can't give any orders to sort the data. These data can't have any meaningful orders. Their values are distributed into distinct categories. Here are some examples. What could be categorized as a nominal data? Color of hairs, for example, brown, red, brown, or black, etc. Here are some examples what can be categorized in nominal data. Example, we have the color of the hairs, brown, red, brown, black, etc. Or marital status, whether the participant is single, widows, or married, and what the national of a participant. Here are some examples of data we categorize in nominal data. Here are some information of data which can be categorized into normal data. For example, we got color of hairs, brown, red, brown, or blacks. Or a marital status, whether the participant is single, widows, or married. And it can be the nationalities of the participant. For example, it is volunteers, German, Americans, and whether they were male or female or others, and what the color of their eyes, whether the black, the brown, etc. So this information can be categorized in nominal data. In this part, we learn what the qualitative data which is categorized in ordinal data. So ordinal data have natural ordering where a number is present in some kind of orders by their position on the scale. These data are used for observation like a customer satisfaction, happiness, etc. But we can't do any arithmetical tasks on them. Ordinal data is qualitative data for which their values have some kind of relation. Ordinal data is a qualitative data for which their values have some kind of relative positions. These kinds of data can be considered in between qualitative and quantitative data. The ordinal data only shows the sequences and cannot use for statistical analysis. Compared to nominal data, ordinal data have some kind of orders that is not present in normal data. Here are some examples of ordinal data. When companies ask for feedback, experience, or satisfaction on a scale of 1 to 10. Here are some examples of ordinal data. For example, when companies ask for feedback, experience, or satisfaction on a scale of 1 to 10. So the participants who join this kind of providing feedback to the company, they're going to select whether they choose 1, 2, or 10 for their input to this. Or it can be the later grades in the exam. For example, grade A, grade B, or grade C, something like that. So the participant, how many of them? Here are some examples of ordinal data. When companies ask for feedback, experience, or satisfaction on the scale of 1 to 10, the participant who join this answering the question or providing the feedback to the company, they will choose the number with their reference, whether they choose number 1 or number 10 or number 7. Here are some examples of ordinal numbers. Here are some examples of ordinal data. When companies ask for feedback, experience, or satisfaction on the scale of 1 to 10, participants who answer this question or here are some examples of ordinal data. When companies ask for feedback, experience, or satisfaction on a scale of 1 to 10, participants who provide the feedback to the company will choose their preferred numbers to state their experience, their satisfaction, either 1, 5, 6, or 10 according to what they benefit from the companies. Or we may use a letter grade in exam to identify those kind of ordinal numbers. For example, whether the student got grade A, grade B, grade C, or grade D. We can rank people in a competition. How many people in the first class, second, or the third, or etc. Or we can identify the economic status, whether the participant in a high economic status, a medium, or in the love status. Even in education levels, whether they finish high school, secondary school, or primary school. So the information collected from this kind of participant regarding as a ordinal data. This table presents the differences between normal and ordinal data. So on your left hand, you can see this table presents you the differences between nominal and ordinal data. On the left column, you can see the nominal data, and on your right columns, this table presents the differences between nominal and ordinal data. Here you can see the column on the left is about nominal data, and the column on the right is about the ordinal data. In nominal data can't be quantified. Neither they have any intrinsic ordering, while the ordinal data give some kind of sequential orders by their position on the scales. And other nominal data is qualitative data or categorical data, while the ordinal data is said to be in between qualitative data and quantitative data. Under the category of nominal data, they don't provide any quantitative value, neither can we perform any arithmetical operation. While the category of ordinal data, they provide sequence and can assign numbers to ordinal data, but cannot perform the arithmetical operation. Nominal data cannot be used to compare with one another, and ordinal data can help you to compare one item with another by ranking or ordering. For example, the eye colors, housing styles, gender, hair colors, religion, marital status, ethnicity, etc. is a part of nominal data. And the example of economic status, customer satisfaction, education level, letter grade participants do in their exam are classified under the category of ordinal data. So when you try to differentiate this kind of category, it would give you some information to collect the data for interpretation. Quantitative data can be known as categorical data. Quantitative data can be expressed in numerical values, making it countable and including statistical analysis. These kind of data are also known as numerical data. It answers the question like how much or how many and how often. For example, the price of a phone, the computer's RAMs, quantitative data can be called quantitative data can be called categorical data. Quantitative data can be expressed in a numerical values, making it countable and including a statistic. Quantitative data can be known as categorical data. Quantitative data Quantitative data can be called categorical data. Quantitative data can be expressed in numerical values, making it countable and including statistical quantitative data. Quantitative data can be called categorical data. Quantitative data can be expressed in numerical values, making it countable and including statistics. Quantitative data, known as categorical data. Quantitative data can be expressed in numerical values, making it countable and including statistical data analysis. These kinds of data are also known as numerical data. It answers the question like how much, how many, and how often. For example, the price of a phone, the computer RAMs, the height or weight of a person, etc., falls under quantitative data. Quantitative data can be used for statistical manipulation. This data can be represented on a wide variety of graphs and charts, such as bar graphs, histograms, scatter plots, box plots, pie charts, line graphs, etc. Here are further examples of quantitative data. Here are some further examples of quantitative data. Here are some examples of quantitative data. Here are some further examples of quantitative data. Height or weight of a person or objects. Room temperature, score and marks from exams, times are categorized into this group of quantitative data. Here are some further examples of quantitative data. A height or weight of the person or objects, which we measure or we scale them, the room temperatures, or the score and the marks students get from their works, or the time they start to work, would be counted as quantitative data. Here are some further examples of quantitative data. Examples: height or weight of the person or objects, room temperatures, scores and marks. Examples: 59, 80, 60, which students get from their works, time they start working, are categorized into quantitative data. Quantitative data can be classified into descriptive data. The term discrete means distinct or separate. Quantitative data can be categorized in discrete data. The term discrete means distinct or separate. Quantitative data can be categorized in discrete data. The term discrete means distinct or separate. The discrete data contain the values that fall under integers. Quantitative data can be categorized in discrete data. The term discrete means distinct or separate. The discrete data contain values that fall under quantitative data can be categorized into discrete data. The term discrete means distinct or separate. The discrete data contain the values that fall under integers or whole numbers. The total number of students in a class is an example of discrete data. These data can be broken into decimal or fraction values. The discrete data are countable and have finite the discrete data are countable and have finite values. Their subdivision is not possible. These data are represented mainly by a bar graph, number lines, or frequency table. The discrete data are countable and have finite values. Their subdivision is not possible. These data are presented The discrete data are countable and have finite values. Their subdivision is not possible. These data are represented mainly by a bar graph, number lines, or frequency table. Here are further examples of discrete data. Total number of students present in a class, cost of a cell phone, number of employees in the company, the total number of players who participated in the competition, days in a week. These information are known as discrete data. Here are further examples of discrete data. Total numbers of students present in a class, cost of a cell phone, numbers of employers. Here are some further examples of discrete data. Numbers. Here are some examples of discrete data. Total numbers of students present in a class, cost of a cell phone, numbers of employees in the company, the total number of players who participated in a competition. Here's some example of discrete data. Here are some further examples of discrete data. Here are some further examples of discrete data. total number of students present in a class, cost of a cell phone, numbers of employees in a company, the total number of players who participated in a competition, days in a week. Here are some further examples of discrete data. Total number of students present in a class, cost of a cell phone, numbers of employees in a company, total number of players who participated in a competition, days in a week, are fall into the category of discrete data. Quantitative data can be categorized in quantitative data can be divided into continuous data. Continuous data are in the form of fractional numbers. It can be the version of an Android phone, the height of a person, the length of an object, etc. Continuous data represents information that can be divided into smaller values. Quantitative data can be categorized into quantitative data can be divided into continuous data. Continuous data are in the form of fractional numbers. It can be the version of an Android phone, the height of a person, the length of an object. Quantitative data can be categorized in quantitative data can be defined. Quantitative data can be categorized in continuous data. Continuous data are in the form of fractional numbers. It can be the version of an Android phone, the height of a person, the length of an object, etc. Continuous data represents information that can be divided into smaller values. Quantitative data can be categorized in continuous data. Continuous data are in the form of fractional. Quantitative data can be categorized in continuous data. Continuous data are in the form of fractional numbers. It can be the version of an Android phone, the height of a person, the length of object, etc. Continuous data represents information that can be divided into smaller levels. The continuous variable can take any value within a range. The key difference between discrete and continuous data is that discrete data contain the integers or whole numbers. Still, continuous data stores the fractional numbers to record different types of data such as temperature, height, weight, time, speed, etc. The key difference between discrete and continuous data is that discrete data The key difference between discrete and continuous data is that discrete data The key difference between discrete and continuous data is that discrete data contain the integers or whole The key difference between discrete and continuous data is that discrete data contains the integers or whole numbers. Still, continuous data stores the fractional numbers to record different types of data such as temperatures, height, weight, time, speed, etc. Here are further examples of continuous data. These included height of a person, speed of a vehicle. Here are some further examples of continuous data. These including height of a person, speed of a vehicle, time taken to finish the work, Wi-Fi frequencies, market shares price, and etc. Here are further examples of continuous data. Here are some examples. Here are some further examples of continuous data. These including height of a person, speed of a vehicle, time taken to finish the work, Wi-Fi frequencies, market shares price, etc. Here are some further examples of continuous data. These including height of persons, here are some further examples of continuous data. Here are some further examples of continuous data. These including height of a person, speed of a vehicle, time taken to finish the work, Wi-Fi frequencies, market share price, and so on. The table below shows the differences. You can use the table below to compare the differences between discrete and continuous data. On the left column is about the discrete data, and the right column is about continuous data. So under the category of discrete data, you can see that you can use the table below to compare the differences between discrete and continuous data. The last column is about the discrete data, and the right column is about continuous data. Discrete data can be, you can use table below to compare the differences between discrete and continuous data. The left column is about discrete data, and the right column is about the continuous data. In discrete data can be countable, finite, and the whole numbers or integers, whereas continuous data are measurable, they are in the form of fraction or decimals. Discrete data are represented mainly by bar graph, whereas continuous data are represented in the form of histogram. The values in discrete data cannot be divided into subdivision into small pieces, whereas the values in continuous data can be divided into subdivision into smaller pieces. The discrete data have spaces between the values, whereas continuous data in the form of a continuous sequence. The example of total students in a class. Here are some examples regarded as discrete data. The total number of students in class, number of days in the week, size of a zoo, These are examples of discrete data: total students in a class, number of days in a week, size of a shoe, etc. And the example of continuous data is the temperature of the room, the weight of the person, a length of an object, and etc. Here is the process of collect data. After you know the nature of data, now it is time to know how you can collect the data. After you are familiarized yourself with the nature of different type of data, after you have familiar with the nature of data, now it is time to know. After you are familiar with the type of data or the nature of data, it is time to know. After you are familiar with data or the nature of data, it is time to know. After you are able to differentiate the different natures, after you are familiar with the different nature of data, now let's talk about how can we collect those data. First, you need to consider if the data is a primary or secondary. We have to consider how to collect your examples. After you are familiar with the nature of data, it is now time for us to, after you are familiar with the different nature of data, now it is time to think of how do we collect data. It is important to consider if our data is primary or secondary. We have to consider how to collect our samples, and we have to consider how to make our samples is representative of a population. After you are familiar with different type, after you are familiar with the nature of data, it is time to think of is the data is a primary or secondary. How do we collect our samples? And how to make sure our sample is representative of a population. Here we can define data collection. Here it is important to understand what is data collection. Data collection is when you gather information in mathematical. Now it is important to understand what the data collection is. So data collection is when you are. Now it is important to understand the data. Now it is important to understand what the data collection is. Data collection. Now it is important to understand what a data collection is. Collecting data is often. Now it is important to understand what the data collection is. Collecting data is when you gather information in mathematics which you can then categorize or organize. Now it is important to understand what the data collection is. Collecting data is when you gather information in mathematics which you can then organize and analyze to answer questions. To do this effectively, you need to know about different data collection methods. The table below here shows you if your data is a primary data, secondary data, qualitative data or quantitative data, discrete data or continuous data which we were discussing earlier. So I don't have to mention about quantitative or qualitative data again, but it is important to see what the difference between secondary data and primary data. Primary data collection can be done by direct observation using data collection sheets or a two-way tables. Here it is important. Here it is important to understand what the data collection is. Collecting data is when you gather information in mathematics, which you can then organize and analyze to answer questions. To do this effectively, you need to know about different data collection methods. Now, it is important to understand what a data collection is. Collecting data is when you gathering information. Now, it is important to understand what a data collection is. Collecting data is when you gather information in mathematics, which you can then organize and analyze to answer questions. To do this effectively, you need to know about different data collection methods. This table is the summary of data information which we may have already mentioned earlier. But it is also important to be able to differentiate between primary data and secondary data. Primary data collection can be done by direct observation using data collection sets or two-way sheet tables. This table is a summary of different types of data, which we have already mentioned previously. However, it is important to be able to differentiate between primary data and secondary data. Primary data collection can be done by direct observation using data collection sets or two-way tables. This data is collected directly by the person who is going to analyze it. Secondary data is that taken from data that is taken from a secondary source rather than collected directly is known as secondary data. For example, the secondary data can be the source of the book, or the source can be found from the internet. Data that is taken from a second source rather than direct data that is taken from secondary source data that is taken from a secondary source rather than collected directly is known as secondary data. Secondary data that is taken from a secondary source rather than collected directly from the participants. This known as the secondary data. Secondary data source could be books or the internet. The researcher who collect the information from books, from the internet, or other source, which is not collected directly from the participants, is still regarded as the secondary data. You can collect data from the whole group. The whole group is known as population. An example of this is a census, which takes place every 10 years in most countries in the world to collect data about people who live or work in those. The process of gathering this data is time-consuming, but It is very useful for planning public services such as healthcare. A more practical way to gather information for data analysis is to carry out a surveys on a smaller section of the population. The smaller selection is known as a sample. There are some important points to consider when taking an example. There are some important points to consider when taking a sample. Representation. Ideally, you want a sample to accurately represent the whole population. There are some important points to consider when taking a sample. Representation. Ideally, you want to There are some important points to consider when taking a sample. Representation. Ideally, you want a sample to accurately represent the whole population. Certain sampling methods, such as stratified sampling, are better for this than others. Sample size. The bigger the sample size, the more accurately it will represent the whole population. However, a bigger sample size means more times and more money will need to be spent on the sample. Bias. Bias in data collecting refer to data which may distort the result of the research, as it is not truly representative of the situation you are studying. It is very important to avoid bias in data collecting. This might happen when you collect data from a small subset of the population. In this part, it is important to think of the percentage which can be represented of the subset of the population. There are some important points to consider when taking a sample. Representations. Ideally, you want a sample to accurately represent the whole population. Certain sampling methods, such as stratified samplings, are better for this than others. Sample size. The bigger the sample size, the more accurately will be represent the whole population. However, a bigger sample size means more time and money will need to be spent on the sample. Bias. Bias in data collecting refer to data which may distort the result of research, as it is not truly representative of the situation you are studying. It is very important to avoid bias in data collecting. This might happen when you collect data from a small subset of the population. Here is about the data collection methodologies. A methodology is an explanation of a data collection process. When carrying out research studies, the data collection process can have a significant impact on the data qualities. Different methods of data collection have their own advantages and disadvantages. Each research method must be considered to ensure that the person that is collecting the data processors, can make an informed Each research method must be considered to ensure that the person that is collecting the data processors, can make an informed decision about the method of data collection to provide high-quality data for their research. Data collection techniques include questionnaires, including online questionnaire, interviews, focus groups, observation, or case studies. The technique you collect data In order to collect data, we can use several techniques. For example, we can use interviews, observation, survey and questionnaire, direct measurements, case studies, and story of change, document analysis, the research in literatures, tests, secondary data sources, focus group discussion, photograph, and videos. Using questionnaire and online survey. A questionnaire or online survey consists of a list of standardized questions about a specific topics. They can be distributed to a large sample of population and returned to the data processor quickly using data collection tools such as the internet. Questionnaires are one of the most common types of data collection as they can be cost effective and when the data Questionnaires are one of the most common type of data collections as they can be cost effective and when the questionnaire is well structured can provide enough detail of satisfies the requirement of the researchers. Questionnaires are one of the most common type of data collection as they can be cost effective and when the questionnaire is well structured can provide enough detail to satisfy the requirement of the researchers. We can use questionnaires Marketing campaigns regularly use the internet, specifically social medias, to broadcast new ideas and products to the markets, often follows up by a questionnaire to provide feedback about the product or service that have been sold. A questionnaire can contain a mixture of closed and open questions. Closed questions have a fixed response that can be answered by ticking a box or selecting value on a scale. Closed questions are used to collect quantitative data, as you can quickly determine the number of participants and select marketing campaigns. Marketing campaigns regularly use marketing campaigns regularly use marketing campaigns regularly use the internet, specifically social media, to broadcast new ideas and products to the market. Marketing campaigns regularly use the internet, especially marketing campaigns regularly use the internet, specifically social medias, to broadcast new ideas and products to the markets, often follows up by questionnaires. Marketing campaigns regularly use the internet, specifically social medias, to broadcast new ideas and products to the markets, often follows up by a questionnaire to provide feedback about the product or service that has been sold. A questionnaire can contain a mixture of closed and open questions. Closed questions have a fixed response that can be answered by ticking a box or selecting a value on a scale. Closed questions are used to collect quantitative data, as you can quickly determine the number of participants that select each option. A questionnaire can contain a mixture of closed and open questions. Closed questions have a fixed response that can be answered by ticking a box or selecting value on a scale. Closed questions are used to collect quantitative data, and you can quickly determine the number of participants that select each option. Here are some examples of questionnaire. For example, the questionnaire below is a closed question because the response can be only one of the options provided. For example, you have the question about how people use transportation to school. And then the people, they can tick in the box whether they walk or they use a bus or car to school. And here is example of open-ended question. The open-ended questions are used for qualitative research, where the answer to be questioned is more descriptive, and therefore it cannot be answered using a simple tick box. For example, the question below is an open-ended. The questionnaire can be open-ended question. Open-ended questions are used for qualitative research, where the answer to the question is more descriptive, and therefore It cannot be answered using a simple tick box. For example, the question below is an example of open. For example, the question below is an open-ended question because the response is more descriptive. The participants in this research have to answer the question about what is your opinion on the number of green space in the university campus. So they can express their opinion on this, which is known as open-ended question. And the data we collected from the response is a qualitative data. There are limitations with questionnaire compared to other data gathering methods. One of the main issues is the lack of respondents. Participants in research studies usually need an incentive to complete a questionnaire. They may take the form of an external motivators such as a discount or free entry into a prize draw, or there could be an intrinsic motivator such as a strong emotional response or feeling of charities. Without incentive, researchers Without incentives, research study can struggle to collect enough data for their research to be for any Without incentives, research study can struggle to collect enough data for their research to be of any significance. Without incentives, research studies can struggle to collect enough data for their research to be of any significance. Without incentives, research study can struggle to collect enough data for their research to be of any significance. Another limitation of questionnaires and online survey is the fixed scheme of questions, which does not allow participants to elaborate, explain further on their choice. It is also important that participants understand the question that is being asked, which the data processors cannot check if they are not in attendance when the questionnaire is being answered. Another limitation of questionnaires and online surveys is the fixed schemes of questions, which does not allow participants to elaborate or explain further on their choice. It is also important that the participant understands the question that is being asked. Another limitation of questionnaires and online survey is the fixed schemes of questions, which does not allow participants to elaborate, explain further, Another limitation of questionnaires and online surveys is the fixed scheme of questions, which does not allow participants to elaborate or explain further on their choice. It is also important that the participants understands the question that is being asked, which the data processor cannot check if they are not in attendance when the questionnaire is being answered. This can lead to unanswered questions or answers that are based on misinterpretation of the question. The interviews and focus group. We can collect We can also collect information from the interviews and focus group. Interviews are usually conducted between the researchers and an interviewee. Interviews provide a chance for interviewee to elaborate on the answers in more details, which may provide more informative data. However, interviews are time consuming and are more costly than other qualitative methods of data collection. Focus groups allows a group of participants to answer questions whilst being able to listen and share ideas with other members within the group. Focus groups are useful as they can be more time efficient and informative. Focus groups allows a group of participants to answer questions while being able to listen and share ideas with other members within the group. Focus groups are useful as they can be more time efficient and informative compared to the other data collection techniques. However, the focus groups Focus groups allows a group of participants to answer questions while being able to listen and share ideas with other members within the groups. Focus groups are useful as they can be more time efficient and informative compared to other data collection techniques. However, the dynamics of the individual members of the group can skew the results. To minimize the risk of a biased data set, the participant should be selected using appropriate sampling techniques. This is important for any research study being carried out. Another way to collect information Another way to collect information from participants, we can use observation or case studies. Participant observation is a useful data collection technique to collect real-time qualitative research. For examples, a social experiment is carried out on a group of 6-year-old children into their communication techniques with one another. By observing their behaviors around each other, researchers can recognize different methods of communication between the children rather than through difficult process such as an interview where the children may not understand research question or may not be able to explain communication techniques with their peer to the researcher providers. We can collect information through observation and case studies. Participant observation is a useful data collection technique to collect real qualitative research. For example, a social experiment is carried out on a group of 6-year-old children into their communication techniques with one another. By observing their behaviors around each other, researchers can recognize different methods of communication between the children rather than others. By observing their behaviors around each other, researchers can recognize different methods of communication between the children rather than through difficult processes such as interviews where the children may not understand research questions. By observing their behaviors around each other, researchers can recognize different methods of communication between the children rather than through difficult processes such as an interviews. By observing their behaviors around each other, researchers can recognize different methods of communication between the children rather than through difficult processes such as an interviews where the children may not understand research questions or may not be able to explain communication techniques with their peer to the research providers. You can have more information about data collection by viewing this kind of video shows. You can learn more methods of data collection from viewing this kind of videos.
Data collection methods are ways of directly measuring variables and gathering information. They allow you to gain first-hand knowledge and original insights into your research problem. You can choose just one data collection method or several methods in the same study. Let's dive into a few of the most common choices and look at some concrete examples of how you can use different methods. Hi, I'm Jessica from Scribr, here to help you achieve your academic goals. Surveys allow you to collect data about opinions, behaviors, experiences, and demographic characteristics by asking people directly. There are two main survey methods to choose from. You can ask people to fill out questionnaires themselves, or conduct interviews where you ask questions and record the answers. Questionnaires are more common in quantitative research. They usually include closed questions with multiple choice answers or rating scales. This allows you to collect consistent data from many people and analyze the responses statistically. For example, if you want to measure student satisfaction with their online classes, you could use a questionnaire to collect responses from many students. Interviews are more common in qualitative research. They usually allow participants to answer questions in their own words. For example, you could conduct interviews to understand how teachers prepare for their online classes and explore which aspects they struggle with. Unlike with questionnaires, you can ask follow-up questions and explore ideas in more depth. However, interviewing is more time-consuming and involves a smaller group of participants. Observations allow you to collect data unobtrusively, observing characteristics, behaviors, or social interactions without relying on self-reporting. For example, to research teachers' skills in online teaching, you could observe their classes directly. Observations may be conducted in real time, taking notes as you observe, or you might make audio-visual recordings for later analysis. Quantitative observation involves systematically measuring or counting specific events, behaviors, characteristics, etc. With this method, it's important to have clear and objective rules to ensure you count the same thing consistently. For example, let's say you're collecting data on how often teachers have tech problems. Does an internet connection issue count, or will you only include problems that are within the teacher's control? You need to clearly define the categories and criteria of your observation in advance. Qualitative observation involves taking detailed notes and writing rich descriptions of what is observed. This means you don't have to decide in advance how to categorize your observations. For example, in an ethnographic study, you might take notes describing how students and teachers interact in the online environment. In theory, observations allow you to collect data on how people really behave and not just how they say they do. But keep in mind that being observed may make people behave differently than they normally would. There are many other data collection methods that are common in different fields. Here are a few examples. In media and communication, you might collect a sample of text to be analyzed. For example, speeches, articles, or social media posts. In psychology, you might use technologies like neuroimaging, eye tracking, or computer-based tasks to measure things like attention or reaction time. In education, you might use tests or assignments to collect data about knowledge and skills. In the physical sciences, you might use scientific instruments to measure things like weight, blood pressure, or chemical composition. But wait, what if you don't have the time or resources to collect data from the population you want to study? Instead of collecting your own data, you can use secondary data that other researchers already collected. For example, data sets from government surveys or previous studies on your topic. With this raw data, you can do your own analysis to answer new research questions that weren't addressed by the original study. Using secondary data gives you access to much larger and more varied samples that you could collect yourself. However, it also means that you don't have any control over which variables to measure or how to measure them, so the conclusions you can draw may be limited. Now here's a tip. If you're struggling to choose the best methods for your research, try reading relevant studies in your field to see how they went about it. Once you know which methods you want to use, you also need to plan out the details of how you use them. Join me in the next video to find out more. Data collection methods are ways of directly measuring variables and gathering information. They allow you to gain first-hand knowledge and original insights into your research problem. You can choose just one data collection method or several methods in the same study. Let's dive into a few of the most common choices and look at some concrete examples of how you can use different methods. Hi, I'm Jessica from Scribr, here to help you achieve your academic goals. Surveys allow you to collect data about opinions, so you've
Thank you for joining us with this kind presentation.